Hi everyone. So I want to go over two now with the non-homogeneous case, but we will do now also the homogeneous case. We will do the whole thing, right? So find the general solution is for number 17. That means we have to do as well the homogeneous as the non-homogeneous. And the equation is y double prime plus 6y prime plus 9y equals e to x 3 minus 5x. Okay, so let's see that everything is as it's supposed to be. This is linear with constant coefficients, so we know how to do this if it's homogeneous. That's the first thing we're going to do. And this one is of the form that we want. It's exponential times a polynomial. Okay, so step one. Let's look at the complementary homogeneous equation. So that is y double prime plus 6y prime plus 9y equals 0. So we have a characteristic equation. The characteristic equation, what is that? That's t squared plus 6t plus 9 equals 0. Okay, so what's going on here? Well, this actually, if you kind of are quick, you see that this actually is a double product formula. It's t plus 3 squared. In other words, two numbers that multiply to 9 and add up to 6, that's both 3 and 3. So what does this mean is that, as we say, so the root is t is negative 3, right? Negative 3 has multiplicity 2. Okay? Keep that in mind. We might or might not need this. Step 2. Oh, no, well, step 2, no, step 2. We're still dealing with the homogeneous. Let's write down what it is. Okay, this is important for our general homogeneous solution. Because we know that if there's only one root, which is the same as saying there's root in multiplicity 2, both things are the same, then we have, well, we always have this e minus 3x, but we cannot write it twice, and therefore what we get is x times e minus 3x. Okay, that's the other part, the other solution of the fundamental system. Okay, that is just the theory from the homogeneous solutions. So now step 2. What do we do? Well, we look at this here. This is the form that we want. The thing that matters is the alpha is 2 here. So we again, perhaps now we don't need that. What we're looking for, we're going to look for a solution of the form u times ex. Okay? So we know that u will be a polynomial. It's a little bit a question, what is the degree of this polynomial, how many, it's a method of undetermined coefficients, and this u will be given a, b, c, and d, so depending on the degree of this polynomial. But let's first try to get the differential equation for just u. So, okay, let's see. What do we do? Well, we have to find y prime. That is u prime ex plus u ex, luckily because we have this x here. Oh no, it's 2x. I'm so sorry, it's 2x. Right, we have to take this one, right? We have to take alpha is 2. So this is 2x here, but we get a 2 here. Okay, y double prime. We have to take the derivative of this whole thing. The derivative of the first is u double prime, copy the second, plus now copy the first, take the derivative of the second, plus now we get 2 times u prime e to x, that's the derivative of the first, and now we get 4u e to x. The 4 comes from the 2 times 2, right? Okay. You can see that these combine. You can do this now or you can do this later. Let me just not bother with it, and so write down now this equation here. So I'm going to plug this into my general equation, okay? So that is... I know there's an e to x here. That part, because I don't like to write e to x each single time, I can factor it out. So we have a u double prime, that's y prime. So here it comes y prime, right? This is u double prime plus 2u prime plus another 2u prime, I haven't put them together, plus 4u. That is this one. Then we have 6 times y prime, that is u prime plus 2u. Remember the e to x are taken out, right? And then plus 9 times y, which is just u, right? Because the e to x is out, and this is equal to e to x 3 minus 5x. The whole point is, what this does is, if you notice, it gets rid of the exponential. And so we reduce to the polynomial. And so what is it then? Let's write it now combined. We have a u double prime, that's like terms. We have a 2u prime, and a 6u prime. That is 10u prime. We have 4u, a 12u, be careful, right? And a 9u. So this is 12, 16, 25u. Equals 3 minus 5x. Okay. So now is the question, so what polynomial do we choose now? Okay. And this depends, in this case we see there's no problem, and therefore we're going to take simply a polynomial of degree 1. Notice that why is there no issue here? Because alpha is 2, and that is multiplicity. Is not a root of the equation. So the multiplicity of alpha in this equation is 0. There's only one solution, and it's -3, which is not 2. So that's why everything is very simple, and we know that u has to be of the form a plus bx. So u prime is then equal to b, and u double prime is actually 0. Okay. So what does that give me? So this gives me 10b u prime plus 25a plus bx is equal to 3 minus 5x. Okay. So let's write everything what we have here. We have a 10b plus 25a. And then we have a plus 25bx, and that is equal to 3 minus 5x. It might be a situation that this u double prime is 0. No, that's fine. Let's see what we have here, because we can compare the coefficients, right? This is the constant, and this is the coefficient of x here. So we have to, what we want is as many conditions as we have unknown, undetermined a, b's, and so on, right? So that is 3. And then the other one is 25b is -5. So this one we can solve first, that b is minus 1/5. Then plug it in there, we get 10 times minus 1/5 is -2, plus 25a is 3. So 25a is 3 plus 2 is 5. So a is 5 over 25 is 1/5. So what our conclusion is that our u is equal to 1/5 a minus 1/5, no, 1/5, sorry, no, the a is 1/5, I shouldn't write it, right? Minus 1/5 x. That is our solution of u. What is y then? Well, let's factor out the 1/5. 1 minus x times, remember, the only difference is that we have an e to the 2x here. So step 3. This is a particular solution, right? Now, that might not be the solution that satisfies the initial conditions, which did I write them up? No, I haven't copied them. I'll write them up down here. I mean, it's in the textbook, right? So what is our general solution? Well, we take this particular solution and then add the general homogeneous solution, which is the thing that I had here, right? Plus a e to the minus 3x plus bx e to the minus 3x. Yeah, so of course in this method we have several times a's and b's, right? And as long as we don't mix a's in one part with a's in the other part, there is no problem. Okay, so in step 2 we used an a, b, but they are done. We don't need them anymore because we determined them, and so now we can use a and b again. And so this is now the initial condition. Sorry, the initial condition was no, sorry, what was the question? Number 17, no, number 17, sorry. Number 17 is, oh, there was no initial condition, sorry. So this is the general solution. Okay, good. And then the other question was number 27. Yeah, so number 27. This is a little bit more work, right? So, so we have y double prime minus 3y prime plus 2y equals e to the minus 2x times 3 plus 4x minus e to the x. Let's see that I didn't copy anything wrong. Okay, and here they say don't find the general solution, which we can, and I'm actually going to do that. Okay, let's just do that. It's one more step, so that's not that much. Step 1, the homogeneous companion of complementary. Sorry, I sometimes say complementary companion equation. So that would be y double prime minus 3y prime plus 2y equals 0. So the characteristic equation is t squared minus 3t plus 2 equals 0. It's easy to factor. That is t minus 2 times t minus 1, right? Yes. 0, so we see t is 1 and t is 2. You have each multiplicity 1. And so the general homogeneous solution looks like there's nothing special here. We use these 1 and 2 as the coefficients in front of the power of x, and so inside the exponential, and that is b e to x. Okay, that is that. Step 2. Now what do we do? This is not of the form that it should be. Right, oh yeah, so what we did, let me write it up. What we would look is, we have this, this is the general form, right? Let me just write down what was the type of equation that we looked at in this section. Something of this form. Exponential times a polynomial. What do we have here is two exponentials, two different exponentials, right? So the first, what we do then is now we do the method of superposition. And it means we just superposition, right? We just take each of them, or the principle of superposition they call it, we take each of these two separately. Now you could even split this in two separately, but that is wasted energy, right? True that if you only look at this one here, that it's probably simple to solve. But the 4x, you say, okay, then I have only one power there. But it is, we will see that even if there's only one x, we have seen examples, I think, you still need a general polynomial of degree 1, which has an a and a b in it. So whether you split this polynomial or not, you're going to always have to do an a plus bx. So keep these two together, right? So in other words, if we use the method of superposition, only take the ones that have different exponentials. Okay, so that means that we have to do 2, right? So 2a, that is the equation, let me write down, y double prime minus 3y prime plus 2y equals the first of these two, e minus 2x, 3 plus 4x. And is there a problem? No. Let's see, this here alpha is negative 2, be careful. So there's no clash here, so we don't anticipate any problems, but let's just see what we get. So we get here y is equal to u e to the minus 2x, that is our method of variation of parameters. So we do that, then y prime is u prime e minus 2x minus 2 u e minus 2x. I hope I can go quick over these things, right? You've done this so many times. Here we do the product rule. Here we do, again, the product rule on the first one, take the derivative of the first, copy the second, and then here, the 4 is the minus 2 times minus 2, u e to the minus 2x. We put this all in this here, we get, again, e to the minus 2x we can factor out, so we have a u double prime minus 2u prime minus 2u prime plus 4u, that is just y double prime. Then we have minus 3 times this guy here, that is a u prime minus 2u, and then we have plus 2 times y, and that is just u. And that is equal to e to the minus 2x, 3 plus 4x. And now we can cancel the e minus 2x. Don't do that too early, right? Don't say, oh, the e minus 2x is cancelled, so I'm not going to write it. No. Because this, I just want to point this out. does this do anything? You see, oh, you cancel it out, it doesn't do anything. No, it does anything. See, because when each time you take derivatives, because of this chain rule, these -2's and then this 4 comes out. These are created by the fact that there's an exponential here. So you cannot just drop this from the beginning. You can only drop this at the end by canceling. Okay, so let's see now what we have. U double prime, then the U prime -2, -4, another -3, that's -7 U prime. And then we have 4u. Don't forget this is -3 times -2 is actually +6u. 10u plus 12u, so 12u. And that is equal to 3 plus 4x. Now, of this, be careful. We don't want to solve this in general. We don't need to. Here we only find a particular solution because that's what we are after, right? At this point, in step 2, we have already found our homogeneous solution. So now we're looking for particular solutions, so also for u. Okay, so don't start solving this quadratic equation, the quadratic equation, all that. That's no, we don't do that. So what is this tells us? We know, and again, so here is of course important since alpha is 2, alpha is -2. So the multiplicity of alpha is 0. We know that u is just going to be a plus bx. We'll see what happens in the next for the next one. Okay, and then u prime is then b, and u double prime again is 0. Might seem strange, but it's okay. It works. We plug this in, we get 0 minus 7b plus 12a plus bx is equal to 3 plus 4x. So that is minus 7b plus 12a plus 12b is equal to 3 plus 4x. That gives us minus 7b plus 12a. The constant is 3 on both sides, and this side it is 12b equals 4. So we see that b is 1/3. You see fractions are almost inevitable here. And so if that b is 1/3, sometimes they do nicer, but this time they're not so nice. Okay. I forgot to write an x here. Did I screw? Wait, did I make a mistake? No, double checking. Minus 7, minus 2, minus 2, minus 3, okay, and 4 plus 6 plus 2, 12, okay, yeah, okay, so I want to make sure that, I don't want to write down something wrong and then have to check it later, so let me quickly see with my notes here that I'm going the right way. Yeah, this 27, right? They don't have fractions, so and I do have these fractions. So what did I just minus 3 minus 4 minus 3, that's minus 7, okay, and then we have 4 plus 6 is 12, okay, so if I plug in, take derivatives, minus 7b plus 12a plus bx is 3 plus 4x, it's 3 plus 4x, right? Unless I copied that wrong, but okay, so, out, very out, okay, so let's plug it in, so minus 7/3 plus 12a is 3, so bring this to the other side, so 12a is 3 plus 7/3, that is 9/3, 9/3 plus 7/3 is 16/3, so we see a is 16 over 36, which is 4 over 9. Yeah. Okay, let's move on. I might have made a slight mistake, but that's just... so that is the solution when we only have this term. But we also have the other term, so we have to solve this one more time. So here the solution, well, the U solution was A was 4/9 plus 1/3 x, and then y this solution for, so this is the first part. Let me write y1 here. That is 4/9 plus 1/3 x times e to the minus 2x, right? That is where we wrote down our y. Where did we write it down? Here, right? Okay. But that's only for the first one. So what is the second one? So 2b, I guess. Now is the equation becomes the same. We have, the same equation, right? Y double prime minus 3y plus 2y equals, what is the other term? Minus e to the x. But, so alpha is 1 here, so the main thing to observe here, alpha is 1, and so the multiplicity in the characteristic equation is 1. So this is now 1. This is something that we'll need to take into account later on. Okay, so I just want to make sure that I didn't copy the wrong question now. I don't know why my answer looks differently than in the back of the book. 27, right? 3 plus 4x, yeah, I copied it right. Oh, no, I didn't. There was a minus sign here. Oh, shoot. Okay, so this is a minus sign. I'm going to see where my minus signs have to come. So this is a minus sign. This is a minus sign, so this is a plus sign. Basically, I have to switch all the signs. Minus, plus, plus, minus. Okay. No, okay. Right, no, sorry. I don't need to do that. Sorry. No. That's not necessary. Right, exactly. Because I'm writing u times ex. U is a polynomial. It will have negative coefficients. Okay, sure, fine. But that's not the issue here. It's now that here I have to write. So it's minus 3 plus 4x. That's where the minus has to go. So what we get here is minus 3. Let me write this again. Minus 3 minus 4x. Okay. So I copied that wrong. That's why. So this is minus 3, and this is minus 4. Right, let's see what we get now. Let's erase everything else. Done so far. Let's see where we get nice coefficients now. My eraser is not working very well, huh? Okay, here we go. So, okay. Yeah, it doesn't really change that much because now b is minus 1/3. Oh, it's okay. Sorry. Now I see what the mistake is. I put the minus sign on the wrong spot. Okay, I'm going to do the whole thing over. I'm sorry about that because otherwise it's going to get too messy. So let me do it over here. I just copied this wrong. Okay, and that's why everything is going. I apologize. This happens, right? I'm sure that you guys had to do this often too. And it's good that you notice it. So it is a minus here and a plus there. That's where I was wrong. It's minus e to the 2x 3 plus 4x. And that is crucial here because now alpha is 2 and that has multiplicity 1. So this already is going to change the way things are drastically. Let's see. Okay, so we do y equals u e to x, right? This minus sign is part of the polynomial, right? So that's why I don't need to write it. Okay, so y prime is then equal to u prime e to x plus 2u e to x. Y double prime is u double prime e to x. That's then u plus 2u prime e to x plus 2u prime e to x plus 4u e to x. It's the same as before, but now there are no negative signs. Okay, so we put everything together. We get the e to x that we can factor out. So I'm plugging this. I'm going to plug these three guys in here now. Okay, so we get u double prime. We have a plus 2u prime, another plus 2u prime, plus 4u. That's this guy. Let's make sure that we have everything. Minus 3. Then we have this u prime, plus 2u. See, I open the parentheses, right, because this minus 3 will multiply each of these terms. And then finally we have a plus 2 times y, which is the u here. And that is equal to minus 3 plus 4x times e to the 2x, and now the e to x is cancelled. So what do we get? We get u double prime plus 2, 4, minus 3. So plus u prime, right? And then you have 4 minus 6 plus 2. That cancels. So u prime is minus 3 plus 4x. Let me expand the negative sign here. Minus 3 minus 4x. So, and this is where things are, we know that this, we know that there's a problem, that it's going to be a little bit more complicated because the multiplicity is 1, okay? So if we look at this equation, it also tells us that something weird is going on. We don't have a u anymore, okay? So if we would put in a polynomial of degree 1, what will we get? So remember, the polynomial was a plus bx. There's no u, there's only u prime, and the derivative would therefore be b. And this would be 0. And then we would get b equals to something with the power of x in here, so that's not possible. So we know that because we have a multiplicity 1, our general solution of u is going to be a linear polynomial, a plus bx, degree 1, it's the same degree as this degree, but we have here the m1, so it is x times a plus a bx. So I remind you, in general, it was, we do x to the power, the multiplicity, times a general polynomial. So this was a general polynomial of degree d. Whatever the degree, if this was a polynomial of degree d, the original one was a polynomial of degree d here. Here, if this, oh, no, I cannot write twice p. So if the degree of p is d, then here this would be a general polynomial, let me call it q. So u is of this form, but this also has the same degree. So here the multiplicity is 1, so we know that's why we have the x here, and then a plus bx, because the degree of this polynomial of this that we left is degree 1. So that's why we have this guy here. Okay, so of course when we need to take derivatives, so it's better to expand this, right? So we get this. So now we can calculate u prime, that is a plus 2bx, and now there is going to be u double prime, because look, what we get is actually a quadratic polynomial that we are suggesting now for you, not a linear polynomial. And I repeat, the reason that we have to do this is it won't work if we just take a linear polynomial. That's how you can tell that you're doing wrong. And the reason that it doesn't work is because we have the alpha is a multiplicity, is with positive multiplicity, is a root. This alpha is a root of the equation. And of course, things could be even worse if this would have been multiplicity 2. There's no example here that we will see, but let's work it out. So this is that, so this derivative of this is 2b. Okay, now I can plug this into my equation here, so I'm working here. And remember, I'm looking for a particular solution. So we get 2b plus a plus 2bx equals minus 3 minus 4x. So we compare the coefficients. The constant is 2b plus a, and that is negative 3. And we have then minus 4 is equal to 2b, so we see that b is negative 2, so now we're not getting, now no fraction, so that's what I want to see. So we get minus 3 is equal to minus 4 plus a, so there's 4 minus 3 is a, and so a is 1. So our solution is u1. The solution, let me just write u here, and the solution of is this one here, right? Or rather this one, a, which is just 1, plus minus 2 times x squared. Now, this is the solution for the part where the first part. So remember, we have this forcing function here that we have split. We're going to split this forcing, sorry, it's over here. We're splitting this forcing function in two different ones, and we have to solve each separately. So this one is solved now, and it is equal to x minus 2x squared times e to the 2x, right? Okay, let's see. Yeah, that is y1. Now we need to do the same thing for this equation. Let me write it up again. e to the minus x. I hope that this time I'm getting it. No. What is with me and my minuses? I guess, I don't know. It's minus ex, minus e to the x. Okay. Right. So, what do we do? Well, we know that's what we do. We take this exponential and we multiply it with u. Now you might say, oh, the professor, can we not just put a constant here? We know that's going to solve for constants. No. Again, alpha is 1 and its multiplicity is 1 in the characteristic equation. So it's not only the first one has a problem, the second one also gives a problem. So I cannot, you'll see, u is not going to be a constant. Okay, so let's find out what we get here. Y prime is then u prime ex plus u ex, that's easy. Y double prime is then u double prime ex plus u prime. Now I'm taking the derivative of ex, but it's of course just ex. Take the derivative of u, copy u, and take the derivative of x. Plug this all in, I get ex in front, and now I can work out this whole thing, right? So I get u double prime plus u prime plus u prime plus u. That's the, I'm taking care of this one. Now minus 3 times these guys. That is u prime plus u, and then plus 2 times u. And that is equal to minus 1 times ex, and the ex is cancelled. Oops, here, be gone. And so what we have is a second order constant terms, but now in u. Let's see, we have u prime plus u prime minus 3u prime, that is minus u prime. Okay, u minus 3u plus 2u. Again, we expect this now. We know that this is going to happen. If this multiplicity is not 0, then we're going to get equations, things are going to disappear. And in fact, if m is 2, I think I've seen, we have seen one problem, but perhaps in the review I'll do another problem like that. Then even in this equation, so what we get here, there's no u anymore, right? If m is 2, we won't even have a u prime. Okay, so this is equal to minus 1. And what we know, the theory says that u is going to be, what is happening? This has degree 0. So it is here, this is my formula, right? It is x to the m times a general polynomial of degree d. d is 0, so that's a constant. So it's a constant times x to the power 1, because the multiplicity is 1. So this is how my solution looks like. Now, that's very easy to see. U prime is then a, and u double prime is 0. You say, oh, this is going to be a problem. No, it's not going to be a problem. Plug it in, and you see the 0 minus a is negative 1, and there you go. A is 1. So although this multiplicity is something, if this multiplicity is higher, you have to pay attention to what you're doing, but the calculations become simpler, actually. That's kind of funny, right? It's a harder case, but the calculations are simpler. There's less to do. So what does this now mean? This means that u equals a is 1. So 1 times here, right? 1 times ex, that's the solution to this equation here on top, the 2, what I called 2b. But that is only the second part of my superposition problem. So this is y2 is I'm sorry. I mean y2 is e to the x, right? U is just 1. Sorry, that's I jumped the gun here. U is 1, right? Well, we found it here. We said u is a. Oh, so no. Hey, see. Plug everything in the right spot. What is u? U is x, because a is 1, sorry, and then y2 is u times ex, so x ex. Okay, let me write it again. So here, right, in this, u is x, and so y2 is x ex. Now, step 3, what is the general solution? Well, the particular solution is y1 plus y2, and then we have the general homogeneous solution. So we kind of add all these different parts up. And that is why this is called linear equations, because we can do this summing up separately. So for those that, oh, what happened here? For those that know linear algebra, this these differential equations are linear in the sense that they preserve sums. Okay, so let's see what we have. Our homogeneous one is aex plus be to the x. Oh no, y1, sorry, y1. Let's do different. That was x minus x squared e to the 2x. That's the y1, right? Then y2 was x, ex, and then the general homogeneous was where was it? Aex plus be to the x. Aex plus be to x. That's the general equation. And by the way, again, this, look, if you double check is how things are as it's supposed to be. So ex here, these two terms have an ex and factor out, and you have an x plus, well, a and b we haven't determined, it's a general solution, right? So this is degree 1 polynomial now. So here in front of ex is not a general polynomial, but it becomes general polynomial if you add these two terms. And same here, this has a constant term, but the constant term is actually there. And so if you would have now initial conditions, let's say, just for the fun of it, y0 is 1 and y prime 0 is also 1. I'm just going to choose something. So additional question. Suppose we have this, so then we have a step 4, right? So if we on this additional question, what we have to do is now we plug in x is 0 and y is 1. This is y. Okay, 1 is equal now. This all this stuff is gone. So we have only a plus b. It's not that bad, right? But we need y prime, and that of course is now a little bit work. The derivative of the first one here is 1 minus 2x e to the 2x plus x minus x squared e to the 2x times 2. There's a 2 here, but on the derivative of e to x. That's the derivative of this guy. The derivative of this guy is ex plus xex, and the derivative of that guy is aex plus 2b e to x. And now we plug in 0. This is supposed to be 1. If I plug in 0, then I have a 1 here. This is 0. This is 1. This is 0. All this thing is 0. We get another 1 here. This gives me 0 again. This gives me an a, and this gives me 2b. So this would be, if I bring this all to the other side, this minus 1 is equal to a plus 2b. And we had 1 is a plus b. So if I do minus 1 this one and add it up to that one, then I get 1 plus 1 is 2, minus a plus a is 0, minus 2b plus b is minus b. So I see that b is negative 2. And then if I plug this in here, let's see, and plug this in here, right? 1 is a minus 2, so we see that a is 3. So the solution would then be here a 1 and there a 3. Let me not write it up, it was not part of the homework. Okay.